Hello there and welcome back to Tutor the Academy tutorials. So today we are continuing with naming carboxylic acid and its derivatives, and we are focused on the amides. All right, say it with me, the amides. All right, so before we actually get into the details regarding this particular functional group, I first wanted to discuss the priority in naming in regards to all the different functional groups that we've learned thus far. So as I said in the carboxylic acid video, carboxylic acids, they have the highest priority of all functional groups. And then after the carboxylic acid, there's the ester, there's the amide, the aldehyde, ketone, and then the alcohol. And as I also mentioned before, the carboxylic acid derivatives, they are of higher priority than the aldehydes and ketones, primarily due to the increase in oxidation state of the oxygen on the particular functional group. So when we begin discussing amides, the first thing is that the hydroxyl group, so originally the carboxylic acid looks like this, right? So this group is replaced with an amino group, such as NH2, to form an amide. Now, this is where it gets a little bit more complex with the amides because the amino group can be bound to no alkyl groups, or it can be bound to one or two alkyls. So these two hydrogens here, if there is one alkyl group bound, it will be NH, whatever the alkyl group is. If there are two alkyls, it'll be N and then the two alkyl groups. There won't be any H's available. So the H's, think of them as like space holders or seat fillers until another alkyl may come in, or it may not be an alkyl at all, as it says that it can also be bound to zero alkyls, as you see here. And as you see here, it's bound to two, and it's bound to two different alkyl groups. Now, these are named similarly to esters. So remember how with esters, the ending of it was like propanoate. Now, the only difference here is that instead of OA as with esters, it's going to be named an amide. We're going to go through some examples down here just to make it more solid in your brain in regards to naming amides. Another important thing is to name is that the substituents attached to the N are named as prefixes. So remember before with the esters, if we had an ester that looked like this, we would name this first. So this here is an ethyl, ethyl ethanoate. So just like with the N, whatever's attached to the N, that's going to be named first. So let's go ahead and do that down here. So in our first example, we're going to name these two. So here we have a methyl group, and then here we have an ethyl group. Another thing is that whatever's attached to the N, we do not name it. We just name them as prefixes with N coming before that to denote that these specific groups or these specific alkyls are located on the N. So if we look here, we have 1, 2, 3, 4. So we can say that this is butanamide. So if we have to put it all together, it'll be N-ethyl, N-methyl, butanamide. Now let's look at number 2. We have two methyl groups. So this is methyl, so this would be dimethyl. And then here we have 2, so 2 is ethanamide. So when we put these two together, it's just going to be N-dimethyl ethanamide. Now to do the last one here. So this one doesn't have anything attached to the N, so we can just go ahead and name it. So we have 1, 2, 3 groups. So this is going to be propanamide. All right, so hopefully this was a little bit straightforward. If you guys are seeking a little bit more examples on this, we will go through brief examples this weekend in our weekend review. But this does conclude our study on naming amides. But if you guys are still struggling understanding this concept and need a little bit more assistance, feel free to go to our website at www.tutorlyacademy.com to book your first session with us. You also will receive 20% off your first session.